So hello viewers, this is another lecture on transportation problem. In previous lecture we studied optimality. In that particular lecture we studied a problem on Modi method where all Dij are greater than equals to 0. In this lecture we will study a problem where any Dij is less than 0. That is, we will study the concept of looping, how to find loop and then how to solve. So for this we are taking one example, test optimality. Here 3 warehouses and 4 markets, you can say markets or customers or as you wish. So this is a metric. So first, to apply optimality we have to find BFS, and BFS can be obtained by Vogel approximation method, that is BFS by 1. So for this we have to find penalty row and penalty column as did in the previous 2 lectures. So for the penalty row, the first row the minimum element is 3 and the second minimum element is 2 and the second is 1, for the third is 4, and the first column is 3, second column is 5, third column is 1 and the last column is 4, because the minimum element is 5 is at 2 places and the second minimum element is 9. So the difference is 4, and if there are all 5 then no penalty can be found at this. So then at that particular condition we write dash. So select the maximum penalty from these corresponding all the penalties. The maximum penalty is 5, so we have to fulfill this 19 first to this entire column. So the minimum element is 1, for this demand is 90 and the supply is 28, so fulfill this 19 on it and remaining is 9. So this and all the entry of this column is completed, so leave this column and make a new matrix. So this is reduced matrix. So for this again calculate penalties for each row and column. So the penalty for first row is 2, for the second row is 3, third row is 4 and the column 3, 1 and 4. So the maximum penalty is 4 and which is at type places. So we have to select the penalty which has maximum demand to supply. The maximum demand is 18. So we have to fulfill this 18 onto these two elements 5 and 9. So 5 is at 2 places. So which 5 we have to select? We have to select the element where we can consume maximum demand or supply. So if we select this 5, we can consume only 9 demand, and if we select this then we can consume entire demand. So we can consider this and put entire 18 on it. What is remaining? 2. So the entire entry is completed. So move on to the next step. So for this again calculate penalty. The penalties are 5, 4, 4, 3 and 1. So the maximum penalty is 5. So we can put 2 on it. What is remaining? 30. So move to the next step. So again find penalties. 4, 4, 1 and 1. So the maximum penalty is 4 and 4 is at 2 places. So the corresponding demand of supply is 9 and 17. So the maximum is 17. So first we have to fulfill this 17 to this minimum element 3. Put 13 on it. What is remaining? 4. Move to the next element. What is remaining? 9. Now this is a 2 by 2 matrix, so we can fulfill all the entries in this particular matrix. So 9 is there and 9 is there, so the intersection is at 6. So put 9 on it. So make a combined matrix. So this is a combined matrix and we have to put all the entries finding by these 4 matrices into this particular matrix. So W1 M4 is 18, that is add this 5. W1 M1 is 3, 2, and the W2 M1 is 9, W3 M1 is 4 and W3 M3 is 13. So the BFS are x11 is equals to 2, x14 is equals to 18, x21 is equals to 9, x22 is equals to 19, x31 is equals to 4, x33 is equals to 13, and total transportation cost is equals to 2 into 3 plus 18 into 5 plus 9 into 6 plus 19 into 1 plus 4 into 7 plus 13 into 3, which is equals to 236. Now we have to test optimality. So m equals to number of row, which is equals to 3, n equals to number of column, which is equals to 4, and number of allocations r equals to 6, 3 and 3 6. So since m plus n minus 1 is equals to 3 plus 4 minus 1, which is equals to 6, number of allocation. So optimality can be tested. So applying Modi method. So this is the step number 1, matrix for ui and vj. In this step we have to put dot on the element which does not have entry, that is add this 6, 8, 2, 5, 8 and 9, and the rest element which has entry remains as it is, 3, 5, 6, 1, 7 and 3. Now select the row or column which has maximum number of elements. This row 2, 2, 2. This column 3, 1, 3, 1, 1. So the maximum element in the first column. So write corresponding ui or vj to 0, and the rest ui or vj remains as it is, that is 3, 6, 7. Now calculate this vj. So for this vj, this is the element, and for this ui is 6. So from the formula Cij is equals to ui plus bj, we can calculate it. It is equals to minus 5. Similarly, for this element, this is ui is 7. So vj will be minus 4. For this, the Cij is 5, ui is 3. So vj must be 2. So moving on to the next step, matrix for ui plus vj. In this step, we have to put dot from the previous step where the entry exists, that is at these particular points, and the rest dot will converted into the element by this particular formula. So for this, the vj is 5 and the ui is 3. So this will be minus 2. For this, minus 4 and 3, minus 1. For this, minus 4 and 6, 2. For this, 2 and 6, 8. For this, minus 5 and 7, that is 2. For this, 2 and 7, that is 9. Moving on to the next step, matrix for empty Cij. So for this, we are moving on to the combined matrix, that is where BFS exists. So in this particular matrix, we have to put dot where entry exists, and the remaining elements remain as it is, that is 6, 8, 2, 5, 8, 9. Now moving on to the next step, matrix for Dij, which is equals to Cij minus ui plus vj. That is, we have to subtract the matrix obtained in second step from the matrix obtained in third step. So put a dot as it is. Now subtract 6 minus minus 2, which is equals to 8. 8 minus minus 1, that is 9. 2 minus 2, 0. 5 minus 8, minus 3. 8 minus 2, 6, and 9 minus 9 is 0. Now, 1 Dij is less than 0. Since 1 Dij is less than 0, so the solution obtained by worm are not optimal. So for this, we have to put plus theta to the element which has negative entry and make a loop from negative element to dot by putting plus theta minus theta alternately. Now we have to put plus theta to the element which is most negative, that is at -3, and now make a closed loop by horizontal and vertical lines from dot to dot. So we have to move either to this element, and if we move this element then we cannot move further because no dot exists from the upper and lower side. So we have to move there, then move there, no exists. Same as if we move here, then we have to put minus theta on it, then move here, we have to put plus theta on it. Now we can move on it this, that is minus theta, and if we move at this particular place then we have to put plus theta, and then move here, then this should be minus theta, but this maybe this must be plus theta, so we can move directly to this particular place, that is this is a closed loop. Now put minimum of theta. Minimum of theta means minus theta, that is these two minus thetas, and what was the entries on these two particular places. The entries on these particular places, at this place entry was 18, that is 18 minus theta, and at this place the entry was 9, that is 9 minus theta, which is equals to 0. These entries are in the BFS table. So from here what is the minimum, 18 minus theta or 9 minus theta? 9 minus theta should be minimum. 9 minus theta is equals to 0 or theta is equals to 9. So revised table. So this is the original matrix which was given. So here we have to put revised entries. This theta represents the entry. So where it was exist, this was the plus theta. So at this element there was no entry because this was W2 M4, that is X24, and X24 does not have any entry. Here theta exists, that is entry exists. So we have to put 9 here. This is minus theta, so we have to less the entry at this particular point. This is X14, and at X14 the entry was 18, and 18 minus 9 is 9. So put 9 on this particular place. Now this was the plus theta, and at this particular point this is X11, the entry was 2. So we have to put 2 plus 9, that is 11. At this particular place the entry was, this was X21, the entry was 9, and 9 is also remaining because there exists minus theta. So 9 minus 9 0, so we can freed this particular entry, and the remaining entry does not have any effect of theta, so they remains as it is, that is as at X22 the entry was 19, at X31 the entry was 4, and at X33 the entry was 30. So these are the revised. So optimal solution are X11 is equals to 11, X14 is equals to 9, X22 is equals to 19, X24 is equals to 9, X31 is equals to 4, X33 is equals to 13, and total transportation cost is equals to 11 into 33, that 11 into 3, that is 33, 9 into 5, that is 45, 19 into 1, that is 19, 9 into 5 45, 4 into 7 28, plus 13 into 3, that is 39, or which is equals to rupees 209. So here you can see the BFS was 236 and the optimal solutions are 209. That is the total transportation cost minimized, that is optimized. So this is the combined solution of this particular problem. Hope you understand the content of this lecture. If you like this lecture, then like, subscribe and share my channel. Thank you.